Hi guys, Mr. Fernando, and I'm here to go over exponential growth and decay, or like a percentage growth and decay using an exponential function. So just going over a little bit of a recap, right? Today's two equations, you can kind of see that we got two equations here, right? It's really based off of the original exponential function equation that we have. And so it's just defining it a bit more. So today in video, again, skip around. I will just show some straight problems of translating a sentence into one of these equations, and then how do you like evaluate one, right? How do you actually like solve or get an answer to an equation given a certain amount of years in the future. So just going over again, exponential function equation, right? What this is, again, it's an input-output type of idea where this is the original, it's a times b to the power of x, or power to the power of an unknown variable exponent, where a is your initial value for your y or your y-intercept, and you're multiplying that by a common ratio, so a constant multiplication of something multiple times through an exponent, right? What is exponential growth and decay, right? It uses that same idea, but we're using or talking about b, or that common ratio, being a percent of change. Percent of change being either a growth or a decay. So this part right here, I'm gonna change this to green to kind of match this. Notice how I'm highlighting this B green? That's because this part right here is your B. All we're talking about here though is as a percent, or a change as a percent of change. So in context to something. So let's say Miss Fernando's YouTube channel, right? It's growing, so it's growing 5% every month, right? Let's say we're growing it every month. So as a percent, the reason why it's 1 plus r, this r represents that percent, and we're gonna do it as a decimal. I'm gonna do it as a decimal. And what happens up here, right, because we're adding it to 1, that's like 100%. 100% plus my change of 5% each month, you would now have y is equal to a, my starting value, which in this case I don't know quite yet, but my starting value is being multiplied by 1.05 exponentially. This 1.05, that represents 105%. I'm growing by 105% each month. So if I had my starting value, let's say I started at 20 subscribers, 20 subscribers times 1.05 would show me a growth of 5%. And then we have an exponent here, that t, right, to represent however many months I want to do this for, right? If I put the number 5 right there, that's me saying what's a growth of 5% over and over and over again over 5 months. Decay, very similar, right? This is a percent as a decimal. In which case, this time though, it is like a decrease because I'm subtracting it from 100%. So let's say I'm posting videos and I'm not doing so well. So I'm losing subscribers. And so let's say I'm losing 10% every single month. In which this case, it would be 100% minus 10%. That means I'm at a rate of 90%, 90% of my original value. So my equation here would be y is equal to a, whatever my starting amount is, times 0.9, because 0.9 is 90% as a decimal. And this is my rates. This is my rate. So all we've done is that my B, it's a percent of change. We're talking about it in relation to a percent of change. A growth would look like this. I'm going from left to right, I'm going up. A decay, or going down, or a decrease, would look like this. So I'm gonna go ahead and do two problems real quick. So let's say I'm starting at 35,000 and I'm increasing by 4% each year. That would look like y is equal to my starting value 35,000 times, what's my increase here? Well, 100% plus 4% each year would give me, I'm increasing by that 104%, or as a decimal, 1.04 exponentially. And so if I put the number 5 in there, that'd be saying after 5 years. In this case right here, again, same idea. Y is equal to 210,000 times an increase of 12.5 each year. So 100% plus 12.5 would be 100, or a 1.125 exponentially. And so you can show it after each year. So right here, just again, if I want to solve these right, what you do here is y is 10 times, in this case, that's like representing 100% plus 40%, or 1.4 exponentially. This one is, let's say, y is equal to 575 times 100% minus 60%, so I'm a decrease of 60%, or a decay of 60%, so that'd be 0.4 exponentially. Now from this point, I need to give you, find out when x is equal to 4. So in this case, right, that 4 would go here, and it'd go right there, and you'd evaluate, right? You'd go, for this first one, 1.4 to the power of 4 times 10 would give me y is equal to 38.4, rounded. And then this one would be, right, you'd have 0.4 to the power of 4 times 575, and that would give you y is equal to 14.72. So notice how, let's see, that's 40% of 575, but it is exponentially done 4 years in a row, or 4 times in a row. There you go. So that's exponential rate as growth or decay. Good job.